Okay, now let's do problem 2.2. If y is equal to c1 times e to the power 2 plus I times x plus c2 times e to the power 2 minus I times x. Sorry, this x should be the exponent. Where c1 and c2, they're just constants. We need to find the second order linear homogeneous differential equation with constant coefficients that this particular y satisfies. So the general form of this equation would be this. So this is a second order equation, second order derivative, and it's linear in nature, and p and q are constant coefficients. In order to solve this equation, we need to identify what P and Q are. We know that a general solution for an equation, for a differential equation like this, is of the form e to the power sx, right? So if you were to plug in the solution there, you will have s squared times e to the power sx plus s times e to the power sx, sorry, sp times e to the power sx plus q times e to the power sx to be equal to 0, right? All I did was compute the first derivative, which is this, and the second derivative, which is this. And I just plugged in these values in this equation. Now I can safely cancel out the exponent term everywhere, and that gives me s squared plus sp plus q is equal to 0, right? This is our auxiliary equation. Now, given that this is a solution, we already know what the two roots are going to be. This is a quadratic equation, right? So if you solve it, you're going to get two roots, s1 and s2. So from this solution, we know that s1 is equal to 2 plus I, and s2 is equal to 2 minus I. Now, all we have to do is, using these two values, these two roots for s, we need to find out what p and q are. So let's do that. Plugging in s1 will give us s1 squared plus s1p plus q equals 0. And that will be 2 plus I squared plus 2 plus I times p plus q equals 0. Now 2 plus I squared is going to be 2 squared plus I squared plus 4I plus 2p plus ip plus q equals 0. Now I squared is nothing but -1. So 4 minus 1 is going to give me 3 plus 4i plus 2p plus ip plus q equals 0. Or I can just write this as 2 plus I times p plus q, just putting these terms together, will be equal to negative of 3 plus 4i, right? So I can do that. Now, if I were to plug in S2 into that equation, S2 is 2 minus I, right? So I'll have 2 minus I whole squared plus 2 minus I times P plus Q equals 0. Now this will give me 4 plus I squared is -1, minus 4I plus this equals 0. That implies 3 minus 4I plus 2 minus I times P plus Q equals 0, or I'm just clubbing these three terms together, it's going to be 4I minus 3. So we had an equation here Now we have another equation here. All we have to do is solve these two equations together, right? Sorry, we forget that. This is our equation right here. It's the same thing. This one's more sophisticated. So we have linear equations in two variables, right? Where the two variables are P and Q. Now, if we were to add these two equations, what will happen? Let's call this 1 and let's call this 2. Now let's add equations 1 and 2. This gives us 2 plus I times P plus Q. I'm sorry, let's subtract these equations, not add. Let's first subtract these equations. Minus, I'm subtracting 1 minus 2, so we have this minus Q will be, here it's negative 3, negative 4i, minus 4i, minus of minus is going to be plus 3. Now let's cancel out these terms. The Q gets cancelled. Now this can be written as 2p plus ip minus 2p plus ip is equal to negative 8i. Minus 2p and minus 2p, negative 2p, they get cancelled. And you have 2ip equals negative I. Now I can cancel I. I can, it's 2 fourths. So I can write this as p equals negative 4. So we know the value of p. We found it to be negative 4. Now I'm going to plug in p equals negative 4 in equation 1 or 2. I'm just going to plug it in 2 because I can see this readily on screen here. If I did that, it would be 2 minus I times negative 4 plus Q is equal to 4i minus 2. Now that would mean negative 8 plus 4i plus Q equals 4i minus 3. I'm going to cancel 4i here. That will give me Q equals negative 3 plus 8, which is 5. So we have Q equals 5. We found the values of P and Q. So the equation will be, the differential equation will be this will be the second derivative of y plus P is negative 4. So just I'm going to write it as negative 4 times the first derivative of y plus 5 is equal to 0. So this is the differential equation for which the given solution would be a solution.